Okay, welcome. We are starting our first unit of chapter 2 today, but it should be a pretty big review. It's quadratics. So this is going to be titled 2.1 Quadratic Functions. Okay, so hopefully a lot of this, like I said, is a review, but we're going to talk about important things. So a quadratic function is a second degree polynomial. And so what I mean by second degree polynomial is it has an x squared. So if the highest exponent in the polynomial is a 2, then it's a quadratic function. The graph of a quadratic function is a parabola. So that means it's either going to be opening upwards or it's going to be opening downwards. A quadratic function written in standard form is written as f of x equals, I'm going to get some colors involved here. I know it's shocking. A x squared plus bx plus c. Okay, so one of the key characteristics of a quadratic function is the x-intercepts. So we need to know how to solve for the x-intercepts. Now, x-intercepts has many different words. So x-intercepts are also known as solutions. They're also known as roots or zeros. So if I said find the x-intercepts, if I said find the solutions, if I said find the roots, find the zeros, those are all asking you to do the same exact thing. So the two ways that we can solve for our x-intercepts, or often we say solutions, is one to factor. So you guys just got a nice little review on that. And two, using the quadratic formula. Okay, so first, with both of those, if you are going to factor or if you're going to use the quadratic formula, one of the most important things, not one of the most important things, but the first thing that you need to do is make sure the equation is set equal to 0 before you even try to do one of those two. So we're just going to make a quick little note of that. So make sure the equation is set equal to 0 before solving. Now, factoring, you know how to factor, and we'll do an example with that. And then quadratic formula. Remember, the quadratic formula is x equals the opposite of b, so negative b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now, do you have to memorize this? The answer is no, you do not, but you have to know how to use it. So you don't have to have it memorized. I'll put it on the board or whatever for the test, but you do have to know how to use it. Okay, so that's one of our key characteristics. Now, actually, what I'm going to do is I am going to just graph kind of a basic parabola on this little graph right here. So I'm going to put one of the key points that we're going to talk about in a second at 1, -3. And then I'm just going to go up from there. So I just did those 2 points, and then it's 1, 2, 3, 4 over 2, and over 2, and then we know a parabola makes a U shape. Okay, so on that graph, if I'm looking for that first key characteristic, the x-intercept, those are going to be here and here. So that is one of my x-intercepts. That is another one of my x-intercepts. Now you could have one x-intercept. If you had one x-intercept, then that would look like something like this. So it only hits it once. You could have no x-intercepts. So no x-intercepts could look something like this. So those are kind of like all of your variations of x-intercepts. Okay, so you have your first key characteristic, which is your x-intercept. Your second is your y-intercept. So to solve for the y-intercept, it's essentially like what we've done in the past with solving for like any y-intercept. You plug in 0 for x and solve for y. So you just plug in 0 for x and then solve for y, just like you did with linear equations or anything like that. Now, if it's like in standard form, like up above, ax squared plus bx plus c, if it's in standard form, you don't even have to do any work. You can actually just look at the c value. So that's kind of like a nice little shortcut. So when in standard form, you can look at the c value. And the reason that works is, let's say you had a quadratic that was something like this. Well, you're plugging in 0 for x, and so you'd plug in 0 for x, 0 for x, and then solve for y. And what ends up happening, because this has an x, this goes away, this has an x, 5 times 0 is 0, and you're just left with 0 plus 8, which is just 8. So that's why we can just look at the c value there. Okay, so if we're looking at our picture, over here, the y-intercept is that point right there, so where it crosses the y-axis. Oops. There you go. Okay, so that is my second key character or key point. So we have our x-intercepts, our y-intercept. The next one is the vertex. The vertex is probably like one of the most important parts of a parabola. And looking at the picture, the vertex is this point right here. So it's basically like where the parabola changes from either going from down to up or up to down, whichever way it's facing. So the vertex is the highest or lowest point on the graph of a quadratic function. So in this case, it's the lowest point on the graph. So there's nothing that's going to go below that vertex. If it was upside down, so if my graph was like this, the vertex, so that would be here, that would be the highest point. Now when A, and A again is like in standard form, A is this value up here. So when A is positive, the parabola will open upwards. So it's going to be opening like this. And the vertex will be a minimum. Because the vertex is the lowest point, we call that a minimum. This would be a minimum, and I can assume just from looking at that picture that the a value of that quadratic function is positive. Now on the flip side, when a is negative, the parabola will open downwards. So it's looking like that. And the vertex will be a maximum. And so again, if you look, the vertex is the highest point, so it's a maximum point. Now we can easily find the vertex, so it's going to be a formula. So to solve for the vertex, so the vertex is a coordinate. So it's always like a point. In this case, the point was 1, -3. And those coordinates, the x, y coordinates, we use special variables or special letters to represent that this is specifically for the vertex. And those are going to be h for the x coordinate of the vertex and k for the y value of the vertex. So h and k. Okay, so to find h is the one that uses the a formula. And just as a note, so this is the x and this is the y. They're just like we use h and k to represent that they're like special x values, special y values, that's all. So to find the h value of the vertex when it's in standard form, you take the opposite of b, so negative b, and then divide it by 2 times a. So the h value is a formula. So again, I will give you that formula. You have to know you have to know how to use it, but I will give that to you. Okay, so then from there, you have the h value. The k value is pretty straightforward. So if you have an x value of a formula, to find the y value, you just plug it in. So to find the k value, you plug the h value into the original equation and solve for y. So plug the h value into the original equation for x. So you're plugging it into x because h and x are the same thing, and solve for y. Plug the h value into the original equation for x and solve for y. Okay, so then the last important characteristic of a quadratic, of a parabola, is the axis of symmetry. So the axis of symmetry is a vertical line that divides the parabola into 2 equal halves. So the axis of symmetry on our picture, now my picture's not perfect, but the axis of symmetry is this line here. So you don't see it on the graph, but it's there. And if I were to like fold the parabola along that line, the parabola would line up one on top of the other. So it's like symmetric with respect to the axis of symmetry. So this is the axis of symmetry. I always write it as AOS. Okay, so to solve for the axis of symmetry, this is hopefully going to look very familiar because it happened a second ago. That formula is x equals, now we're going to talk about why it's x equals. So x equals negative b divided by 2a, which should look very familiar to you because it is the same as the x value of the vertex. Those are always going to be the same. So the axis of symmetry is always going to be the same as the x value of the vertex. So if you have the vertex, you also have the information to give you the axis of symmetry. Now, the axis of symmetry, like I said, is the equation of a vertical line. On a vertical line, it's an equation, so it has to have the x equals. So this axis of symmetry needs to be written as x equals. So you have to have like x equals 5, x equals whatever. In this case, the axis of symmetry, the equation would be x equals 1. That would be the axis of symmetry. because it's a vertical line that's cutting through 1 at every point. And so that is why we have to put the x equals. If you do not put the x equals, I will not give you full credit for that. Okay, last thing, a quadratic function in vertex form. So we talked about it in standard form. Standard form is like y equals ax squared plus bx plus c. In vertex form is going to be f of x equals, sorry, I'm writing on the line. So f of x equals a. I'm going to use the same color from up here because it's the same a value. For the love. Okay. X minus the h value of the vertex squared and then plus k. Notice it's h from the vertex, k from the vertex. Okay. So that's a lot of information, like basically thrown at you about quadratics, but hopefully that was like kind of jogged your memory about what you've seen for the past couple of years in algebra and algebra 2. Okay, so the first thing we're going to talk about is how to convert something from standard form to vertex form. So I'm going to look at my first example down here. Now, if you notice, I have the example on one side and then I have the steps on the other side. So we're going to go through that. It says write the function f of x equals 4x squared plus 8x plus 7 in vertex form. So it's asking us to take something that's in standard form and change it to vertex form. So it's actually a pretty straightforward process. The first thing you're going to do is you're just going to find the coordinate of the vertex. So again, you're just using the formulas from up above. You're finding your h value and you're finding your k value. So your h value, remember, is just opposite of b over 2a. And then your k value, you plug in h for x and solve for y. Okay, so we're going to start there. Now, before I do anything, I'm just going to label what my a, b, and c values are looking at my quadratic. So my a value here is 4. So the number in front of x squared is always going to be your a value. Your b value is going to be the number in front of your x. So b is 8. So again, it's always going to be the number in front of the x. And then c is your constant. C is the number that doesn't have a variable attached to it. C in this case is 7. So c is 7. Okay, so to find our h value of our vertex, we're just plugging it into that formula. So in this case, h is going to be equal to the opposite of b, so the opposite of 8, divided by 2 times a, which in this case is 4. And then I'm just going to simplify that. So that's going to be negative 8 on top and 2 times 4, which is 8. So negative 8 divided by 8 gets me an h value of negative 1. Okay, so now that I have my h value, I can find my k value. My k value, remember, your h value is just like a special x. It's the x value of your vertex. So all that we're going to do to find my k value is we're going to plug it back into 4x squared plus 8x plus 7, so the original equation, and we're going to plug in negative 1 for x. So it's going to be 4 negative 1 squared plus 8 times negative 1 plus 7. Now, I'm just going to do that whole thing in my calculator. If you want to do it part by part, you'd have to do negative 1 squared first. So that would be positive 1, and then multiply that by 4. So you do your exponents before you multiply. Now, if I were to just do that in my calculator, it would be 4. Notice I put negative 1 in parentheses plus 8 times negative 1 plus 7. And then I get a k value equal to 3. So do whatever you're comfortable with. And honestly, of this process, that's the hardest thing, finding the vertex. Everything else is pretty straightforward. So the next step, so that was step 1. I found the h coordinate, or the h value and the k value. I found the coordinate of the vertex. And now I'm going to identify the a value. The A value we've already identified. The A value is 4. Easy. Then the last step is to plug the A, the H, it's all my colors here, and K into vertex form. Now vertex form we already wrote up here, but let's just rewrite it again. It's going to be A times x minus h squared plus k. Now the only big thing with vertex form to remember is that minus, where it says x minus h, that minus is built into it. So when we, it's always going to be the opposite sign of the h value. So what I mean by that is when I plug this in, so that would be f of x equals a, which is 4, and then x minus, the minus is built in, minus -1 squared. Don't forget the squared. It's a very common mistake. And then plus 3. So what I mean by the x will always be an opposite sign is that a minus and a minus, when I have a negative and a negative, that makes a positive. So the final vertex form would be f of x, oh, the pen's running out, equals 4 times x plus 1 squared plus 3. And so that would be my final thing. So when it asks you to write it in vertex form, all you have to do is basically identify the vertex, identify the a value, and then plug it into what you already know. All of your formulas I will write on the board. Again, you just have to know how to use them. And that's that. So we are going to continue on to the second page of notes. I'm going to pause. I'm going to start a new video just so they're easier to process. So come back for part 2.